Let's take a look at the law of cosines. The law of cosines says that for any side of a triangle, for any triangle, the square of that side, so the square of side A, is equal to the sum of the squares of the other two sides, B and C, minus 2 times the product of B and C times the cosine of A, which is the angle opposite side A. And so there are 3 versions for the law of cosines, depending on which side we want to make the special side, and I guess the other way, depending which angle we want to be the special angle. Because the law of sines applies to any triangle, we can use it to solve triangles even if they aren't right triangles. And what we mean by solving triangles, if we're given some information about a triangle, we want to be able to solve for the other information, determine what the other side lengths and angles are. And the law of cosines helps us in 3 particular situations. If I know 3 sides of a triangle, side, 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 but none of the angles, I can figure out what the angles should be. I can use the law of cosines if I'm given 2 sides and the angle between them, or if I'm given 2 sides and an angle that's opposite one of those sides. This third situation, side-side angle, is a little bit more complicated than the other 2, so I'm going to save that for a separate video. Let's take a look at how we can use the law of cosines to solve triangles that have an arrangement of side, side, side as given information, or given information in the arrangement of side, angle, side. So let's take a look at the side, side, side example. With that arrangement of given information, if you think about the law of cosines formulas, I know all of the little letters. I know all of the side lengths. So I know A, so I could figure out A squared and B squared and C squared, and I also know B and C. And so I can find the angle measures because I can determine, because I know everything else, I can determine what the cosine ratios are for each of those angles. So let's take a look at what that looks like. So if I want to start with angle A, I know that 11 squared equals 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of the unknown angle, the cosine of angle A. So I need to be a little bit careful with how we work with these numbers. 11 squared is 121, 10 squared is 100, 15 squared is 225, and then 2 times 10 times 15 is 300. So the 300 is related through multiplication to cosine of A. So it's like a factor, whereas the others are terms. And so I can combine those terms and kind of move them to the other side. Essentially, I can subtract them both to get them to the other side. 121 minus 100 minus 225. That leaves behind a negative 300 times cosine of A. And so if I divide both sides by negative 300, this calculation is going to give me the cosine ratio. Using a calculator to figure out what those numbers are rather than just kind of try to do it in my head, I guess I could try that, but let's see here. So I get 121 minus 100, of course that would be 21, and then minus 225, I think is going to give us negative 204. So I get negative 204 divided by negative 300, of course that's the same as positive 204 over positive 300. We could simplify that, but let me just take that as it is. That's a cosine ratio, which means angle A can be determined from the inverse cosine function, which takes a cosine ratio and turns it into an angle. So I'm going to take inverse cosine of that ratio, 204 divided by 300. So inverse cosine of that ratio, 204 divided by 300, gives me an angle, and this angle turns out to be in degrees. doing a quick check here. I'm in degree mode. And so angle A is approximately 47.2, let's say 47.2 degrees. In a similar way, I could figure out what angle B and angle C are, and I encourage you to pause the video for a moment and take a few minutes to do that. So I hope you took a few minutes to work on this problem. It turns out that through a similar calculation we can find that angle B is 91 degrees and angle C is 41.8 degrees. And so we've solved the triangle because we know the three side lengths, and now we found the three angle measures. We can check those angle measures in a couple ways. So first off, the largest angle has to be opposite the largest side, and the smallest angle has to be opposite the smallest side. And that's the case. And so 41 is the smallest angle, it's opposite the smallest side of 10, and 91 is opposite 15, and 11, the middle side, is opposite the middle angle. And we could also double check and make sure that these three angles add up to 180 degrees. And I believe they do. If we add these other two together, 4 and 4, we get 80. The 7 and 1 is an 8, but then the 0.2 and the 0.8 adds that, turns that into a 9. And so even though these were rounded, sometimes rounding can cause some errors in this sort of thing. But even though these were rounded, we end up with the three angle measures here adding up to 180 degrees. So I encourage you to kind of think about the next problem. It's a little bit different than the one that we just solved, the side angle side problem. I'm going to end this video and then provide a solution in a separate video. So take a few minutes and try to think about how you can use the law of cosines to solve this side angle side triangle. So to give you a hint, the first thing you want to do is try to find the side length A. So I encourage you to take a few minutes and work on that before looking at the solution video. I hope you enjoyed the video. Thanks for watching.